In this session, we are going to see how to write LED switch program using Keil IDE. So for this, you need to click on Project tab, then click on New Project, New Microvision project. Then it will be asking for the project folder where to store the project files. So in the last session also I have told you need to create a project file or project folder directly under one drive. So I have created a folder in D drive. I have created one folder known as LPC2148 Course. So under D drive you are directly creating a project folder. Don't create it in the desktop because the path for the desktop will be very long. Sometimes the program won't compile. So under one drive, say D drive, you are creating a folder. Open this folder. My previous project was here. You give the project for the project name for the new experiment. So LED switch project. I am giving the name like this. Then no need of giving any extension. Automatically .uvprog will be added because this is a project file. So click on save. Then it will be asking for the target device for which you are going to write the program. Here you are going to write the program for LPC2148. It is from a company known as NXP. Previously it was Philips. So expand this NXP. Expand NXP. From this you can take LPC2148. So all the processor features and the peripherals present in the controller is shown here. You can go through it. Then click on open. So here it is asking for whether you need to add LPC2100 startup code to the project folder. So startup code is a code, it is a .s file which is containing all the initial requirements for running a program like the PLL settings, VPB divider settings, then the mode settings, mode addresses, etc. So you need to add that, then only your program will be working properly. So you can give S. Previously it was there, so it was overwritten now. So this is a startup code. It is already added. When you are opening this, you can see your PLL settings will be there. PLL value was there, right? So the last two bits of PLL VPB divider value was used for representing the clock. Here the last two bits are 0 0. That means PCLK will be your core clock divided by 4. All the details of this PLL settings I have told in my first part of this LPC2148 course. You can go through that. So next you are going to create a project, you are going to create a program file. So you can click on this new, then you can paste the program. I have already copied the program, so I have pasted the program here. So this is a program. So now it is in black color. When you are saving this program as .c, the color of the program will be changing. You can see that later. So now the complete program is in black color since no extension is there. So first statement was hash include LPC21XX for .x. So this H file contains all the SFR addresses, that is special function addresses, and its corresponding name used for representing it. Say for example pincel 0. What is the processor cannot understand what do you mean by pincel 0. So the actual address of pincel 0 will be specified in the header file. For example in the startup.s you can see say PLL value. So say you can take this PLL stat EQU or PLL base EQU this. So what does it mean? You are telling the assembler to give a name PLL base for this address. That is meant by the assembler directive EQU. So similarly, all the addresses of the SFRs will be equated to its corresponding names in the header file. So if you are not adding this header file, you will get error in these steps because it don't know what is meant by this pincel. Address mapping is done here. Then in the main program, what is the first step you need to do? You are connecting P0.0 to switch P0.1 to LED. So both P0.0 and P0.1 you need to configure it as GPIO. That is done by using pin cell 0 register. So you are configuring P0.0 and P0.1 as GPIO using this statement. In the second statement, you are configuring P0.0 as input port using a register known as IO direction 0 register or IO 0 direction. Both are same. IO direction 0 or IO 0 direction, both are same. So by using the direction register, you are configuring P0.0 as input port. Similarly, in the next step, you are configuring P0.1 as output port. Why? Because you are connecting the LED. The explanation of the program was already discussed in the previous lecture, that is part 2. You can go through that, so you will get the whole details of the program. So these are the 3 configuration steps. Those need to be run only once, done only, executed only once. Then the remaining 4 steps needs to be executed in an infinite loop. That is why it is written inside while one. So here what I am doing, I am using a variable known as switch stat. I have defined it here as character. To this I am copying a value which is IO pin 0 and 0x01. So IO pin 0 and 0x01, it is used for splitting the last bit of IO pin 0. So last bit of IO pin 0 is will be getting from the last bit of IO pin 0, you will get the value of the switch, because the last pin of IO pin 0 is connected to bit 0 of IO pin 0. So when you are ANDing IO pin 0 with 0x01, you are actually splitting the last bit or keeping the last bit as intact. All the other bits will be masked with 0. This explanation is also there in part 2. You can go there and see. So the all the 31 bits will be masked except the last bit. That value is stored on the switch status. Then you are checking whether that value is equal to 0, right? After masking all the other bits, and if the last bit is 0, that means the switch is pressed. When the switch is pressed, last bit, that is bit 0 of IO pin 0, will be set as 1. So if it is set as 1, you can identify that switch is pressed. So you need to make the LED on. For making the LED on, you are using IO set 0 register. So LED is connected to P0.1. That means the first bit of IO set 0 will be set. That is meant by this 2. 2 means in hexadecimal it is 0010. That is the first bit of IO set 0 register will be set. So P0.1 will be generating VCC and the LED will be on. And if the switch status is not equal to 1, that means the last bit is not 1, it is 0. Then you need to clear the LED, switch off the LED. How will I do that? You are using a register known as IO clear 0. In that you will be writing the same value, right? So when you are writing 1 in bit 1 of clear register, that pin will be cleared. When you are writing 1 in bit 1 of IO set register, that bit will be set. So when you are writing 1 in IO set, that corresponding pin will be set. If you are writing 1 in clear register, corresponding pin will be cleared. So this is how you are doing a program for controlling an LED with a switch, right? So next step, you can save this program. Save as, you need to save it in the same folder itself. You need to save it as, say, LED switch .c. Here you need to give the extension because the processor don't know, the compiler don't know whether you are writing assembly program or C program. Assembly program will be having extension .s. C program will be having extension .c. So give the extension .c, give save. So now you can see that the color of the program has been changed. Constant's color was violet. The C command was bolded, etc. So now you can identify that the extension was properly saved. Next step is you need to add this program into the project file. How will you do that? You need to right click on the source group, right click on source group, click on add files to group, source group 1, then show that file, give add. So you can see that your program is added here. Then close this window. After adding this, you need to close this window. right? Then few more steps has to be done before building the program. So you need to click on this target options, click on this. First one, you need to verify, you click on this device, you need to verify whether the controller is correct, 2148. Then you click on target. In this target, you by default the ROM starting address and ROM size, RAM starting address and RAM size is already specified, you don't need to change it. Then the crystal frequency by default it is 12 megahertz. Then you need to click on the output tab. Here create hex file option is there, you need to select this or you need to enable this. Then only hex file will be generated so that you can simulate it. Otherwise you will not be able to simulate it, because from the hex file you are going to simulate. Then the last option is you click on the linker tab and select this option, use memory layout from target dialog. What does it mean? You are telling the compiler to take the memory layout of ROM and RAM from the target dialog. What is target dialog? This is target dialog. Here I have specified the starting address of ROM and size of ROM, starting address of RAM and size of RAM. I am telling the compiler to take the RAM and ROM size and the starting address from here by giving a tick mark. Otherwise your program and data will not be stored in the proper location. These addresses are given by the manufacturer itself, you cannot change it. So all the settings are over, you need to set target, output and linker. Then give OK. Then you can give rebuild. So when you are building, you will see that creating hex file is has been generated, and you can see the hex file in the project folder. So wherever you have created the project, inside the project folder you can see a hex file with the name of the project. So LED switch project.hex. So the hex file will be in the name of the project, not in the name of the program. LED switch project.hex, right? If you are not getting this extension, you need to click on organize, click on folder options, then click on view. Here you need to hide, you need to remove this tick mark, hide extension for non-file types. Remove this tick mark, give OK. So all the extensions will be shown. So this is how you are writing a program for LED switch interface. In the next session we will be seeing how to simulate it using Proteus simulator.